Hi. So I would start with my standards, and so I do a lot of visuals just to kind of keep it constant throughout the lesson. Okay. So hi everyone. Thanks for being here. It's really good to see you. How are you doing? Good. Did you do anything fun this weekend? Did you do anything not fun this weekend? How's everything going? Um, and so what we're going to do today is we're going to look at a new standard, and we're looking at chemical reactions. And at the top of the screen, you can see the NGSS standard. That's our next generation science standard. But when you're reading it, you might be like, what? Sometimes I feel that way too. So what I did was I just tried to simplify it a little bit. So what we are going to do today is we are going to use our learning target here. And so today you're going to learn about how electrons move between substances in a chemical reaction. Okay. And you'll know that you've learned it because you'll be able to describe what happens when substances undergo a decomposition reaction, and then you'll be able to predict maybe what would happen in a different type of chemical reaction. Don't forget you have access to this presentation, so after the class is over, if you're going back and rewatching the recording, you can always use the vocabulary button, and so make sure that you click on this button here or on any of the slides as you see it, and it'll take you to our vocabulary slide. So just make sure that you're accessing that if you have any questions about some of the vocabulary that I'm using. All right, so at this point, we'll watch a small video. I use phenomenon-based teaching, so try to get them to relate something that they see or know about. And most of the kids know about elephant toothpaste because they've learned about it in physical science. And so it's just one of those really cool chemical reactions. And so we would watch the video, and I would prompt them before they get started so that they can think about what they already know about chemistry and what they can maybe bring to the table in order to talk about that and what was happening. So watch the video. So what did you see happening? What was going on? What did they add to the beaker? So just lots of guiding questions. And so here I would elicit some student ideas and just try to get them to start thinking about what was actually happening. Based on previous knowledge, these are just investigative pieces. It is not, there is a right answer or wrong answer. I make sure my students always know that in science, all we're doing is investigating what we think. And maybe it's supported and maybe it's not. So, and I take any level of understanding at this point, even if it's I don't know yet, that's okay. Those students who may be unsure, if some students are adding to the board, or if they're adding it in chat. If they're adding it in chat, I might transfer it to the board, or if they're on the microphone, I would transfer it to the board so that all of those are on the board. And then if you aren't sure, maybe use your pointer and pick out which one you think it might be. And so from there, we would move on to talking about the reaction and trying to get them to think about what's happening. So what I have here is just the model of the chemical reaction. What's this part that makes it go fizzy, right? And so I do like a lot of draggable pieces. So I would say, so here is the reaction for elephant toothpaste, or this is at least a portion of the reaction for elephant toothpaste. So hydrogen peroxide, H2O2, is in the reaction, and it is broken down by an enzyme. And when it is broken down, it is broken down into hydrogen gas and oxygen gas. And so I have a picture here, and this means that I am doing this part. And so I would say, I'm going to drag my pieces so that you can kind of see what we're looking at. And so I have draggable stacks here. And so, whoops, that didn't work. There it goes. So here's an oxygen. So we're just dragging our pieces so we can kind of start building what our model looks like. Okay, so I've got 2 oxygens. I would add my 2 hydrogens, which are behind my screen, my webcam, so I'm sorry about that. But basically we're building. And so what I would do next is I would say, I'm going to start thinking about those valence electrons. Can anybody remember what valence electrons are? Hopefully prompt them through to start talking about the main group elements and how they have designated valence electrons, and then using this to kind of bring in their Lewis dot structures so they can start thinking about how those electrons are arranged around our atoms. And then being able to put together the compounds would be the next part, like rearranging so that all the electrons match up into bonds. And I would do that, but I'm asking them questions as I do this so that they can sort of contribute with me and just to get them thinking about these things. And so at this point, I would ask for some sort of understanding. What did you see happening on the last slide? Feel free to go back if you need a refresher because they do have access to this. So hopefully they can use this slide to kind of describe what's happening with the electrons. So where they are in H2O2 versus where they are in O2 and H2. And like I said, I like to just kind of, even if somebody doesn't know, if we can get those pieces on the board, then we would, anybody who's not sure, please go back and, use your pointer and show us which one you think it might be. And then for the next one, I would have them sort of guide me through dragging. I would let them drag if they wanted to. Again, we're doing this together, so instead of just me alone, we're doing it together. And then hopefully they would be able to, sort of create what I did on that first slide, working through, putting those valence electrons on. If we needed to go back and refresh on valence electrons and what they were, which ones we know about, we could do that. And then hopefully that's what they'll generate. And then we would then go into another concept check for understanding, and just making sure that they can self-assess, and then any questions that they have on the board. I do sometimes share questions that I've heard before, or I might be able to come up with on my own, just to kind of prompt them, to give them an example. At this point, I would be sharing a class kick or some other type of online assessment tool, so that students who were feeling pretty good about this, they can go ahead and start working on their own on some other examples, so that maybe they can start on synthesis reactions or double displacement or single displacement. And in class kick, they would, just start being released in that way. Students who felt yellow or orange might stay with me a little bit longer, and maybe we would start going through the class kick together so that they can see sort of what's going on. The class kick would have the exact same sort of model as this with the draggable pieces, so that they can start putting those together And let's see. So like I said, Class Kick would just have that explainer slide for each type of reaction so they could kind of do it on their own. So students are prompted to leave their own feedback. So if they have questions on a particular type of reaction, I can check that and sort of bring that back into class. So, hey, y'all, see a lot of questions about double displacement. Come on back and let's do that together. So this isn't really too much math in terms of my students who might need a little bit math support, but just having that vocabulary that they don't have to necessarily say, hey, I don't know what this means. Hey, I don't know what this means, but just having that available to them, I think that really helps my students with reading comprehension or just understanding, what I'm talking about, because they might be like, oh, valence electrons, what were those again? And so they can click directly on that link and it'll take them to my vocabulary slide at the end. And then my vocabulary slide is here with definitions and a Quizlet linked. Like I said, they always have access to these presentations so that they can go back and look at them again and again, and when they have filled out with all the information too. So I feel like I explained more than taught. So, but here at this point, I would give an exit ticket. Maybe that would be part of their Class Kick, or it might be separate for some of those students who needed a little bit more support. So, but they also would have that Class Kick available so that they can practice on that if they wanted to, in order to get ready for their test. Thank you.